Hey y'all, this is Mrs. James here with Activity 30 in Unit 5. And as you know, Unit 5 is all about graphing quadratic functions. And today's activity is about transformations of quadratic functions. If you think back to Unit 2, we talked about transformations of functions in general. We gave you a parent function, and then you transformed it. You shifted it left, you shifted it right, you shifted it up, you shifted it down, you did all kinds of things. Okay, well today we're looking more specifically at transformations of quadratic functions. Okay, and over the past few lessons you've learned that a quadratic function is y equals x squared, or we can say that of f of x equals x squared. Okay, and what we have here, all right, and I've already filled in the numbers, okay, and graphed them just to save some time. But guys, what we have here is what we call the parent function of a quadratic function, okay? If you notice, this is a U-shaped, and we call this U-shape a parabola, okay? And this is the most basic parent function that there is. So let's talk a little bit about this parent function. So number 2 asks us to use words such as vertex, maximum, minimum, increasing, and decreasing to describe this graph. Well, right here would be my vertex, all right? So I have a vertex of 0, 0. Would that vertex be considered a minimum or a maximum? Think back to those definitions that we learned in Unit 2. Well, guys, this is the lowest point on the graph, therefore this is a minimum. Let's talk about increasing and decreasing. Well, guys, if you notice, the first half of my function, from negative infinity to my vertex of 0, it is decreasing, and then from 0 to positive infinity, it's increasing. So half of my parabola is increasing, half of my parabola is decreasing. All right, so next we have number 3 that talks about the axis of symmetry. Now guys, every parabola has an axis of symmetry. If you notice, this parabola is symmetric. All right, that means if I fold it down that axis of symmetry, everything is going to line up exactly the same. Okay, that's what I love so much about parabolas. It's because I can fold them in half and they perfectly match up. All right, so part A wants me to draw the axis of symmetry. Now guys, the axis of symmetry will always go directly through the vertex. It's a vertical line that goes straight through that vertex. Okay. And anytime I want to write the equation for the axis of symmetry, it will always be x equals some number, okay? Well, guys, that x value is going through 0. Therefore, the equation of this axis of symmetry is x equals 0, all right? So this is the parent function. Now let's start transforming them, okay? So here we have a table and a graph, and shown we have the parent function. So we have the values and we have the graph of the parent function. Well, then we have this new function, g of x, that is x squared plus 3. So they want me to fill in this table and then graph and see what happens. All right, so here we have the values of x squared plus 3 filled in, and I've now graphed g of x on the same coordinate plane as f of x. All right, and guys, if you notice, f of x, or the parent function, is shown in black. G of x is shown in blue. All right, now let's also look at number 7. It says complete the table for f of x equals x squared and h of x equals x squared minus 4. So similar concept. All right, so let's fill in that table and then plot the quadratic function. So now we have a filled in table with h of x graphed. All right, so let's compare. We are asked to identify the vertex and the axis of symmetry for each of the functions shown above. All right, so starting with f of x with the parent function. We've already established that the vertex of the parent function is 0, 0, and the axis of symmetry is x equals 0. Okay, so now let's look at g of x. Well, guys, this new vertex is 0, 3. The axis of symmetry is still x equals 0 because that axis of symmetry goes directly through the vertex. Okay? Now let's look at h of x. Well, this new vertex is 0, -4. And once again, the axis of symmetry is x equals 0. Now let's compare g of x and h of x to the parent function, f of x equals x squared. All right, so guys, if we look, here's the parent, and what happened to g of x? It shifted up 3 units. What happened here to make from f of x to h of x? Well, guys, it shifted down 4 units. The axis of symmetry, the axis of symmetry never changes. But what I notice changes is the y value of the vertex. Okay, so let's see what we have here. It says the changes to the parent function in items 6 and 7 are examples of vertical translations. All right, and a translation of a graph is a change that shifts the graph horizontally, vertically, or both. Okay, so it doesn't change the actual shape of the parabola. It's just going to shift it left, right, up, or down. So, based off what we've seen, how does the value of k in the equation g of x equals x squared plus k change the graph of the parent function f of x equals x squared? Well, guys, we noticed that it shifted it vertically when I added 3. It still shifted it vertically, but I went down when I subtracted 4. So therefore, k will shift the vertex vertically. All right, so now we have f of x equals x squared, and we're going to compare that to k of x, which equals x plus 3 squared. So we have f of x shown in black, and then we have k of x shown in blue. What changed? Well, it looks like I shifted to the left 3 units. Well, let's look at another one. Now we have p of x equals x minus 4 squared. All right, so what we have here now is f of x, and then we have p of x. And if we notice, it shifts to the right 4 units. All right, so let's compare. Once again, the vertex of the parent function is 0, 0. Okay, now what was our vertex on number 13 of k of x? That vertex was -3, 0. And then the vertex of p of x is 4, 0. So let's compare the parent to these 2 new ones. Now the axis of symmetry changed on this one, okay? Because here was the axis of symmetry for the parent. Here's the axis of symmetry for the new function. So the axis of symmetry changed, okay? And the vertex shifted which directions? It shifted either left or it shifted right here. So it shifted horizontally. But what's something kind of funky that we noticed? Okay, well guys, in parentheses it says -4. But where's my vertex? At +4. Let's go back to number 13. It says +3 in parentheses, but I went left 3 units and gave me a vertex of -3, 0. With that in mind, let's answer this next question. How does the value of h in the equation k of x equals x plus h squared change the graph of the parent function? Well guys, this is inside parentheses, therefore it's going to shift the vertex horizontally and opposite of what you would think. All right, so far we've had the original parent function f of x equals x squared. Then we had a new function, all right, that was x squared plus k, and this shifted the parabola either up or down, okay? Then we had h of x equals x plus h squared, and that's going to shift it left or right. And we also want to think opposite. Okay, so we've taken the parent function and we've moved it up or down, we've moved it left or right. Now let's see what else we can do. So here, and I'm sorry, it's kind of small print, but it says complete the table for f of x equals x squared and g of x equals 2x squared. And guys, then we're going to graph it here. And notice the parent function is already graphed. So here we have f of x, and here in blue we have g of x. So guys, what's different? The vertex didn't change here, but if you notice, my parabola is increasing at a faster rate. All right, keep that in mind as we look at number 2. So here we have the parent function, and we're going to compare that to h of x, which is 1/2 x squared. So let's fill in the table and graph. So when comparing f of x to h of x is increasing at a much slower rate. Notice that it's much wider than the parent, okay? G of x up here was a lot thinner than the parent. H of x is a lot wider than the parent. All right, so let's identify the vertex and the axis of symmetry for each of these. Well, guys, the parent function, we know that, okay? Now the parent function of, the vertex of g of x, well, guys, did it ever change? No. Did the axis of symmetry change? No, so it's the exact same. Did the vertex change here or the axis of symmetry? No. The axis of symmetry is still x equals 0 and the vertex is still 0, 0. So guys, it did not shift left, right, up, or down. But the width of the parabola, or the width of the u, did change. Looking at this next example, we have f of x as our parent function, and we have g of x equals negative x squared. So what do you think is going to happen here? My parabola is going to completely reflect across the x-axis. All right, so let's compare. So we have f of x, and we know that the vertex is 0, 0. We know that the axis of symmetry is x equals 0. Well, guys, looking at this new function, g of x, my vertex is still 0, 0, which means my axis of symmetry is still x equals 0. But what's different? All my values have now been reflected across the x-axis. All right, so the change to the parent function in item 1 is a reflection over the x-axis. So guys, what we just saw right here was a reflection of the parabola, okay? So how does the sign of a in the function g of x equals ax squared affect the graph? Well, guys, if a is positive, my parabola will open up. If a is negative, my parabola is going to open down. Therefore, it affects the direction of the parabola. On number 1, we had what's called a vertical stretch by a factor of 2. All right, notice those values are being stretched out. On item number 2, we had what's called a vertical shrink by a factor of 1/2. Those values of the parent have now shrunk down. So, for a greater than 0, so if a is larger than 0, how does it affect the parent function? Well, guys, it will stretch the function, okay? It will stretch that function, make it really, really, really skinny, okay? Now, if a is less than 0, okay, it will shrink the function. So when a is greater, it stretches. When a is less than, it will shrink it. So guys, now let's put all of that together. So we have r of x equals 2 times x minus 4 squared plus 3. Well, the factor of 2 out front will stretch the parabola. The minus 4 on the inside horizontally, opposite here is this transformation graph. That it shifted right 4, up 3, and now increases at a factor of 2. Therefore, my new vertex is 4, 3, and my axis of symmetry is now x equals 4.